This is the EdExcel GCSE 921 Maths High Paper 2 from the November 2021 series, and this paper is a calculator paper. Question number 1. For part A, we have to write down the inequality shown on this number line. Well, what we have here is x being greater than minus 1. The arrow is pointing to the right along the positive x-axis. We have a circle which is not filled, hence x is greater than minus 1. Now, for part B, on the number line below, we have to show the inequality minus 3 is less than or equal to y, which is less than 4. Here is the inequality shown on a number line. In between minus 3 and 4 is where y lies. And you'd notice here we have a filled circle for a weak inequality symbol. Here we have an empty circle for the strong inequality symbol. Question number 2. We have to find for part A the highest common factor of 60 and 84. Well, if we consider the factors of 60, well, 1 times by 60 gives 60. 2 times by 30 gives 60. 3 times by 20 gives 60. 4 times by 15 gives 60. 5 times by 12 gives 60. And 6 times by 10 gives 60. We have listed here the factors of 60. And if we consider 84, the factors of 84, well, we've got 1 times by 84, 2 times by 42, 3 times by 28, 4 times by 21, 6 times by 14, and 7 multiplied by 12. And so when we come to find the highest common factor of 60 and 84, the 12 is the highest common factor. And so therefore the highest common factor of 60 and 84 is 12. Next, we have to find the lowest common multiple of 24 and 40. Well, let's begin by writing out the multiples of 24. We've got 24, 48, 72, 96, 120, and we could continue. If I write out the factors of 40, we've got 40, 120, rather 80, 120, and we could continue, but at this point we can realize that 120 is the lowest common multiple. And so we would have 120. Question number 3. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. We've got the distance travelled in kilometres, and we've got the time of day. And for part A, we have to work out Sam's speed in kilometres per hour for the first 15 minutes of his journey. Well, over here for part A, you can see that we have 20 kilometers travelled in 15 minutes. So we have 20 kilometers travelled every 15 minutes. But what we want to do is convert this to kilometers per hour. And so what we want is 60 minutes on the bottom. And so from 15 to 60 we multiply by 4, and so 20 times by 4 is 80. So we travel at this rate 80 kilometers every 60 minutes, which is the same as 80 kilometers per hour. And so we have 80 kilometers per hour. Then for part B, at 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. For part B, on the grid we have to complete the travel graph for Sam's journey. So at 10 minutes, he stops for 10 minutes. So if I show that, here you can see for 10 minutes he stops, and then he drives for 20 minutes at a speed of 75 kilometers per hour. So 75 kilometers per hour well, what this is the same as is 75 over 60 kilometers per minute. And what we want here is every 20 minutes. And so from the 60 to the 20 we divide by 3. And so here we also divide by 3. 75 divided by 3 is 25. So in 20 minutes we've got 25 kilometers. So for the next 20 minutes we travelled 25. Question number 4. For part A, we have to complete the table of values for y equals x squared minus 2x plus 2. Well, we can use the table function on our calculator. If we were to use the table function, we've got x squared subtract 2x plus 2. We are starting at minus 2. We are finishing at 4. We are going up in ones. So when x is minus 2, y is 10. X is minus 1, y is 5. X is 0, y is 2. X is 1, y is 1. X is 2, y is 2. X is 3, y is 5. And x is 4, y is 10. And so here we have completed the table of values for y equals x squared subtract 2x plus 2 in between minus 2 and 4. And then for part B on the grid, we have to draw the graph of y equals x squared minus 2x plus 2 between minus 2 and 4. We have to plot these coordinates. Here is the graph of y equals x squared subtract 2x plus 2. And then for part C we have to use our graph to find estimates of the solutions of the equation x squared subtract 2x plus 2 equals 4. To do this we need to draw the line x equals 4, and that line is shown over here. We have y equals 4 drawn, and then we read where the graphs cross each other. They cross here at x equals minus 0.7, and also here at x equals 2.8. So we have estimates at x equals minus 0.7 and x equals 2.8. Question number 5. Here is a right-angled triangle. We've got dimensions 10mm and 8mm. The shaded shape below is made from 2 of these triangles, and what we have to do is work out the perimeter of the shaded shape, give your answer correct to 3 significant figures. Well, first of all, we need to find the hypotenuse of the triangle, and we can do that using Pythagoras. So, the hypotenuse h, well, let's first of all work out what h squared is equal to. That is equal to 8 squared plus 10 squared. And if I work out what this is, 8 squared plus 10 squared, that's 164. And so therefore the hypotenuse h, that's equal to the square root of this, which is 2 times by the square root of 41. So we have here 2 times by the square root of 41. And if I work out the decimal equivalent, we have 12.80, etc. millimeters for the hypotenuse. And so to find out the perimeter, well, here along this edge over here, we have 12.80, etc. millimeters. Now, if this entire edge is 12.80, we need to subtract this length over here, which is 10 millimeters, to find out this remaining length here. And so what this is equal to is 2.80, etc. millimeters. So now we've got all the dimensions, and from this we can find out the perimeter. And so therefore the perimeter, we've got 8 plus the 10 plus the 2.80, etc. plus the 12.80, etc. And then we add on this 8 over here. And if I work this out, we have this length plus 8 plus 8 plus the 10 plus this length subtract the 10, which is this bit here. And if I work this out, it turns out we get 41.6 millimeters given to 3 significant figures. So we have 41.6 millimeters given to 3 significant figures. Question number 6. We've got ABC, which is a right angled triangle. We've got AC, which is 12 centimeters. The angle CAB, which is 56 degrees, and we have to work out the length of BC, correct to 1 decimal place. Well, first of all, we need to label the triangle. Here, we have a length which is opposite the included angle of 56 degrees. We have the 12, which represents the adjacent. What connects the opposite with the adjacent is tangent, and so therefore we have tan of 56, which is equal to the opposite, which is BC, divided by the adjacent, which is 12. And so what we need to do is find out what BC is. So BC is equal to 12 multiplied by the tangent of 56, and if I work this out, we end up with, to one decimal place, 17.8. So we have 17.8. And now for part B, PQR is a right-angled triangle, and what we have to do, given that PR is 18 centimeters and QR is 15 centimeters, we have to work out the size of the angle marked X, give our answer correct to one decimal place. Well, similar to before, let's label the sides. We've got the largest side opposite the right angle. This is the opposite. We've got in between the included angle and the right angle, that's the adjacent. What connects the opposite with the adjacent is cosine. So we have cosine X equals adjacent, which is 15, divided by the opposite, which is 18. What we need to do is find out what X is. So X is equal to the inverse cosine of 15 divided by 18, and it turns out we get 33.6 degrees given to one decimal place. So we have 33.6 degrees. Question number 7. Liquid A has a density of 1.8 grams per centimeters cubed, and liquid B has a density of 1.2 grams per centimeters cubed. 80 centimeters cubed of liquid A is mixed with 40 centimeters cubed of liquid B to make 120 centimeters cubed of liquid C. We have to work out the density of liquid C. First of all, we can find out the mass of A, and that will equal, well, what we need to do here is multiply 1.8 grams per centimeters cubed with the 80 centimeters cubed. It's as though the centimeters cubed cancel out, and if I work this out, 1.8 multiplied by 80 is 144. And so here we have 144 grams for the mass of A. If we work out the mass of B, we've got 1.2 grams per centimeters cubed multiplied by 40 centimeters cubed, and if I work out what this is, we have 48 grams. And so what we can do is find out the total mass of C. The total mass of C will equal 144 plus 48, which is equal to 192 grams. And so therefore we need to find the density of C. So the density of C, we've got 192 grams divided by 120 centimeters cubed. So if I work out what this is, it turns out we get 1.6 grams per centimeters cubed as the density of C. Question number 8. The grouped frequency table gives information about the time in minutes taken by 50 people to solve a puzzle. Brian was asked to draw a cumulative frequency table for this information. This is the table that Brian drew, and what we have to do is write down one thing that is wrong with this cumulative frequency table. Well, because we've got a grouped frequency table, all the inequalities should start with 0, and so that's what's wrong. Here, all of the inequalities do not start with 0. Now for question 9, the box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday, and for part A we have to work out the interquartile range of the information in the box plot. Well, we've got the upper quartile, which is 188, so the upper quartile is 188. We've got the lower quartile, which is 50, and so therefore the interquartile range is equal to the upper quartile 188 subtract the lower quartile of 50, which is 138. So we've got 138 minutes. Now for part B, Becky says 50% of the people waited for at least 2 hours. Is Becky correct? Explain why. Well, if we take a look over here, you can see for the median, that corresponds to 120 minutes, which is 2 hours. And so Becky's correct because the median is at 120 minutes, which corresponds to 2 hours. Now, part C, the table gives information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. Becky was asked to compare the distribution of the length of times people waited on Monday with the distribution of the length of times people waited on Tuesday. She wrote people had to wait longer on Tuesday than on Monday, and we have to give one reason why Becky may be wrong. Well, here we've got a median of 100, and the median we found before was 120. So one reason why Becky may be wrong, well, the median on Tuesday, which is 100 minutes, is less than the median on Monday. Question number 10. Louise invests X pounds in better investment for 3 years. Sadiq invests X pounds in County Bank for 3 years with better investments. We've got compound interest 2.5% per annum, and with County Bank we've got compound interest 2% per annum for the first 2 years and 3.5% per annum for each extra year. At the end of the 3 years, the value of Louise's investment was £344,605. What we have to do is work out the value of Sadiq's investment at the end of 3 years. Well, first of all, let's consider what's happening with Louise. She invests X pounds, and then we've got compound interest at 2.5% per annum, so our multiplier is 1.025, and we're investing for 3 years, so we raise this to the power of 3, and it turns out we get 344,605. And what we need to do is find out what X is. So X is equal to 344,605 divided by 1.025 cubed So I've got 344605 divided by 1.025 to the power of 3. And it turns out then x is equal to £320,000. So that's how much Louise invests. And so Sadiq will also invest X pounds. So Sadiq will invest £320,000. So if I take a look at Sadiq's investment, he invests X pounds. And then in the first 2 years, we've got 1.02 as our multiplier. And then we square this because we've got 2 years. And then I multiply this by 1.035. I need to find out what this value is, knowing what x is. So I've got 320,000 multiplied by 1.02 squared multiplied by 1.035. And so, working this out, we get £344,580 and 48 pence. And so the value we require is the value shown here. Question number 11. Here is a sketch of the line L. The points P with coordinates -60 and the point Q with the point 03 are points on the line L. Point R is such that PQR is a straight line and the ratio PQ to QR is 2 to 3. For part A, we have to work out the coordinates of R. Well, if I think about it, from P to Q, I'm going +6 in the X direction, and in the Y direction, I am going +3. And so what I have to do here then, to find out what the coordinates of R is, well, I would have to multiply by 1.5. And so in the X direction, I have the 6, and I need to multiply this by 1.5 because the ratio is 2 to 3. To go from the 2 to the 3, I multiply by 1.5. And so if I work this out, 6 multiplied by 1.5 is 9. So that means I would have to go 9 units to the right, and in the Y direction I have 3 multiplied by 1.5, which is equal to 4.5. So that means I have to go over here 4.5 units up. And so to find out the coordinates of R, 0 plus 4.5, rather 0 plus 9 is 9, 3 plus 4.5 is 7.5. The coordinates of R, we've got 9 and 7.5. And then for part B, we have to find an equation of the line that is perpendicular to L and passes through Q. Well, we want something which passes through Q but perpendicular to L. Well, we can find out the gradient of PQ. So the gradient of PQ, we can find out what this is. We've got the change in Y divided by the change in X. So we've got 3 divided by 6 which is equal to 1/2. Now, if we have something which is perpendicular, that means the perpendicular gradient is equal to the negative reciprocal of 1/2, which is -2. And so for our equation, we have y equals -2x plus 3. The y-intercept is plus 3. So we have y equals -2x plus 3. Question number 12. We have to expand and simplify x subtract 2 multiplied by 3x plus 2 multiplied by 2x plus 3. Well, what this is equivalent to, we've got the x minus 2, and I'm going to multiply this by 3x plus 2 multiplied by 2x plus 3. Well, 3x times by the 2x gives 6x squared, and then we've got 3x times by 3, and we've also got the 2 times by 2x, so we've got 9x plus 4x, which is 13x, and then we've got the 2 multiplied by the 3, which is 6. So we need to expand all of this out. And one possible way is to use the grid method. So I've set up a grid over here showing our multiplication, and if I work all of this out, 6x squared times by x is 6x cubed, x times by 13x is 13x squared, 6 times x is 6x, minus 2 times 6x squared is minus 12x squared, minus 2 times 13x is minus 26x, minus 2 times by 6 is minus 12. So when I collect like terms together, I've got here 6x cubed, and then I've got minus 12x squared plus 13x squared, so that's just 1x squared. 6x subtract 26x, that's minus 20x, and then I've got the minus 12. And so the calculation results in the expression 6x cubed plus x squared minus 20x minus 12. Question number 13. In a school there are 16 teachers and 220 students. One of these students, 120 are girls and 100 are boys. One teacher, one girl and one boy are going to be chosen to represent the school. We have to work out the number of different ways there are to choose one teacher, one girl and one boy. Well, over here I can find out how many girls. Well, I've got 120 girls, 100 boys. There's 16 teachers. So if I choose one teacher, one girl and one boy, the number here, we've got 16 teachers. We've got 120 girls. And we've also got the 100 boys. So if I work out what all this is equal to, I end up with 192,000. Question number 14. We've got A, B, C and D, which are 4 points on a circle. SBT is a tangent to the circle, it's a straight line, and the angle ABD is 20 degrees. The ratio of the size of the angle BAD to the size of the angle BCD is 3:1. We have to find the size of the angle SBA. Give a reason for each stage of your working. Now, what we can do is recognize that opposite angles in a cyclic quadrilateral add up to 180. So this angle plus this angle adds up to 180. And so, using our ratio, we've got 180 divided by 3 plus 1. 180 divided by 4 is 45. So that means we've got 45 degrees per part. And so therefore, we've got, well, let's write down the reason for this. Opposite angles sum to 180 in a cyclic quadrilateral. And so we have BAD, which is equal to 45 times by 3, which is equal to 135. And the angle BCD is equal to 45 times by 1, which is 45. So if I show those angles here, we've got an angle of, well, the angle BAD is 135. And the angle over here then is 45 degrees. Now we want SBA, which is this angle here. Well, the angle SBD, which is this angle here, will equal this angle here because of the alternate segment theorem. So this angle here is also 45 degrees. So let's just write that down. The angle, we've got the angle SBD, which is equal to 45 degrees, and that's because of the alternate segment theorem. So let's just write down the reason properly. We've got SBD, which is equal to the angle BCD, which is equal to 45 degrees. And that's because of the alternate segment theorem. And so to find the angle, question number 15, here is a triangle ABC. We've got AC being 8 centimeters and AB being 11 centimeters, and the included angle CAB is 72 degrees. For part A, we have to find the length of BC to 3 significant figures. Well, using the cosine rule, BC squared is equal to 8 squared plus 11 squared minus 2 times by 8 times by 11 times by the cosine of 72 degrees. 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 72. We end up with 130.61, etc. And so the square root of this is 11.42, etc. So BC is equal to 11.4 given to 3 significant figures. And now we have to find the area of the triangle. Well, the area that's given by 1/2 times 8 times 11 times by the sine of 72 degrees. So if I work out the area of the triangle, 1/2 times 8 times 11 times the sine of 72 degrees is 41.8 centimeters squared, given to 3 significant figures. So we've got 41.8. Question number 16. For part A, use the iteration formula xn plus 1 equals the cube root of the square root of 10 minus 2xn to find the values of x1, x2 and x3, we have to start with x not equaling 2. Well, we've got x0 which is equal to 2, x1 is equal to 10 minus 2 x0 cube rooted. So I have 10 minus 2 times by 2 cube rooted. So if I type in 2 and then the cube root of 10 minus 2 times the answer, our calculator stores in the previous value. So the next value we have is 1.817, etc. x2, we've got 10 minus 2x1, and then this is cube rooted. So I've got 10 minus 2 times 1.817, etc. And then this is cube rooted. So it turns out here I get 1.853, etc. And then x3, I've got 10, subtract 2, x2, and then this is cube rooted. So I have 10 minus 2 times by 1.853, etc. And this is cube rooted. So I get 1.846, etc. And so therefore, we've got our value of x1 being 1.817, the value of x2 1.853, and the value of x3 1.846. The next part, the values of x1, x2 and x3 found in part A are estimates of the solution of an equation of the form x cubed plus ax plus b equals 0, where a and b are integers, and we have to find the value of a and the value of b. Well, this iterative equation is a rearrangement of this equation here. Now, what we have is an equation x equals the cube root of 10 minus 2x square rooted. And we need to rearrange this. So, if we rearrange this to write this in the required form, cube both sides, we end up with x cubed equaling 10 minus 2x, and taking everything over to one side, we have x cubed plus 2x minus 10 equals 0. So the value of a is 2. The value of b is minus 10. Question number 17. Some people took part in the first round of a competition. The histogram gives information about the scores of these people in the first round. 20% of the people got a score high enough for them to qualify for the second round. We have to work out an estimate for the score needed to qualify for the second round. You must show all your working. Well, what we need to do here is find the frequencies. We can do this by finding the areas of each bar. 5 times by 0.8 8 is 4. 10 times by 1.6 is equal to 16. 10 times by 2.2 is 22. Then 15 times by 1.2 is 18. We have found the associated frequencies. And so what do we need to do over here? Well, let's first of all find out the total number of people. I've got 4 plus 16 plus 22 plus 18, and if I work this out, it turns out we get 60. So we've got 60 people in total. Now, 20% of 60 is equal to 12. Now, ultimately, I want 12 people, and I need to find the score that would give us the 12 people, and I need to consider the upper end, because that way I can find out the number of people needed. Now, the way to go about this is to think, if I've got a height over here of 1.2, I need to find the width of the rectangle. And so we want the area of 12, and if I call the width W, we've got W, well, we'll do it in a different colour. We've got W multiplied by the 1.2, which would give us the 12. We want to consider the upper end because that will find the score needed. And so therefore, you will find W to equal 10. So what I want from this then is a width of 10, and so the required score is clearly 40 take away the 10, which is 30. And so therefore 40 take away this 10 is equal to 30. Here is a graph of y equals sin x for x being in between 0 and 360. For part A, using this graph, we have to find estimates for all 4 solutions of the equation sin x equals 0.6, where x is in between 0 and 720. Well, if I draw a horizontal line from 0.6, as we see here, so this is y equals 0.6, then hopefully what you can see is we've got our first 2 values from here. We've got 37 and we've got a value of 143, or around that value. So we've got 2 values over here so far. We've got 37 and 143. But what we need to recognize is sine repeats every 360. So we need to add on 360 to these values. So to find my next value, I need to add on 360 and if I do that, 37 plus 360 is 397. And then to find the other value, again, I need to take this value and add on 360. And if I do that, I get 503. And that's recognizing that sine is periodic. It repeats every 360 degrees. Now, the graph of y equals sine x is reflected in the x-axis, and we have to write down the equation of the reflected graph. Well, if I reflect in the x-axis, that means I have y equals minus sine x. Then, here is a graph of y equals f of x, and on this grid we have to draw the graph of y equals f of x minus 2. Well, going from y equals f of x to the graph of y equals f of x minus 2, this over here is a translation by the vector to 0. I need to shift this graph 2 units to the right. And if I do that, well, this point, shift it 2 to the right, and then this point here, 2 to the right, and then we go 1 across, and then this point is going to end up over here. So here is the graph of y equals f of x minus 2. Question number 19. A, B and C are 3 spheres. The volume of sphere A is 125 centimeters cubed. The volume of sphere B is 27 centimeters cubed. The ratio of the radius of sphere B to the radius of sphere B is 1 to 2. And what we need to do is find out the ratio of the surface area of sphere A to the surface area of sphere B. Now, if we consider the volume scale factor area, well, let's write this out. We've got length scale factors. We have area scale factors, and we also have volume scale factors. And we've got A, B, and C. Now, the volume scale factor, A to B, we've got 125 to 27. Now, can this be simplified? 125, can I divide that by 3? I can't. This can't be simplified. But then I need to cube root each of these to find the length scale factors. And so here I would have 5 to 3 as the ratio of the lengths of A to B. Now I already know that B to C is 1 to 2. So I've got the ratio of B to C in terms of lengths is 1 to 2. And so here I have 1 times 3, which is 3, and 2 times by 3, which will be 6. And so, for the area scale factors, I need to square. So I've got 25 to 9 to 36. And for the volume scale factors, I need to cube. 6 cubed is 216. Now I want the ratio of the surface areas of A to C, so that will be given by 25 to 36. And that is the ratio A to C. Question number 20. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecast says there is a 70% chance that it will rain in the village on Monday. We have to work out an estimate for the probability that it will rain in the village on Wednesday. You must show all your working. The best way to do this question is to consider a tree diagram. And that's what I've drawn over here. We've got Monday, Tuesday and Wednesday. Now let's fill in what we know. The probability that it will rain on Monday is 70%, which is the same as 0.7. So does not rain, that's 0.3. Now let's consider the next day. If it rains, then the probability that it rains the next day is 0.8. So if it rains, the probability that it rains again is 0.8. So the probability that it does not rain the next day is 0.2. So here we've got 0.8 because it rains and then it does not rain. Now we have to consider the situation for what happens when it does not rain on one day, then it rains the next day. So if it does not rain and then it rains, that's 0.6. So what's happening here is it does not rain and then it rains, so that's 0.6. So does not rain is 0.4. So if it does not rain, then it rains, that's 0.6. And then if it does not rain and then does not rain again, that's 0.4. So if it rains and then it rains again, that's 0.8. And then does not rain is 0.2. And if it does not rain, the probability that it rains is 0.6. And does not rain is 0.4. So what I need to do now is find out the probability that it rains on the village in Wednesday. So let's think about how we could do this. Well, it could rain on Monday, rain on Tuesday, rain on Wednesday. So we've got 0.7 times 0.8 times 0.8. That's one way we could go about things. Now let's see if there are any other ways. Well, I still want it to rain on Wednesday. So if I want it to rain on Wednesday, well, how do I go here backwards? Well, it could rain on Monday, then not rain on Tuesday, but then rain on Wednesday. So here I've got 0.7 times 0.2 times 0.6. Now I still want it to rain on Wednesday, so if I want it to rain on Wednesday, how could I get that? Well, I could have it not raining on Monday, then raining on Tuesday, then raining on Wednesday. So if I work that out, I've got 0.3 times 0.6 times 0.4, rather times 0.8. And then for it to rain on Wednesday, well, I could have it not raining on Monday, not raining on Tuesday, but then raining on Wednesday. So I could have as well 0.3 times 0.4 times 0.6. So this is the probability I need to work out. So I've got 0.7 times 0.8 times 0.8. So that's the first combination. Then I've got 0.7 times 0.2 times 0.6. I've got 0.3 times 0.6 times 0.8. And I've also got 0.3 times 0.4 times 0.6 and it turns out I get 0.748. So this 0.748, this would correspond to the probability that it will rain in the village on Wednesday. Question number 21. The time period t seconds of a simple pendulum of length L centimeters is given by the formula t equals 2 pi times the square root of L over G. Katie uses a simple pendulum in an experiment to find an estimate for the value of G. Her results are shown here. We've got L is 52.0 correct to 3 significant figures, and t equals 1.45 correct to 3 significant figures. And what we need to do is work out the upper bound and the lower bound of the value of G using pi equals 3.142, and we need to show our working. Now what we'll do over here is we'll rearrange for G. So if I've got t equals 2 pi multiplied by L over G square rooted, then I can square both sides, leaving me with t squared equals 4 pi squared, so we need to square the 2 pi as well, multiplied by L over G. And I want to get G by itself, so if I multiply through by G and then divide through by t squared, we can conclude G then will equal 4 pi squared L divided by t squared. Now what we need to do is calculate an upper bound and a lower bound. So what we need is the upper bound and lower bound of L and t. The upper bound of L is 52.5, rather 52.05, because this rounded, rather 52.05, and the lower bound of L is 51.95. So here we've got the upper bound and lower bound of L. We've also got the upper bound of t, which is 1.455, and then we've got the lower bound of t, which is 1.445. These rounded to 3 significant figures gives the values of L and t. So for me to calculate the upper bound of G, that's equal to 4 pi squared times by, well, if I want the upper bound, that will equal the, well, what I need here is 4 pi squared times by the upper bound of L divided by the lower bound of t all squared. So I've got 4 times by 3.142 times by 52.05 divided by the lower bound of t squared. So I've got 1.445 squared. So the upper bound of G, if I work this out, I've got 4 times by 3.142 times 52.05 divided by 1.445 squared. So let's just double check this. Got squared over here. So it turns out we get 984.36 77853. So that is the upper bound of G. And if I do the same thing for the lower bound of G, I've got 4 pi squared times by the lower bound of L divided by the upper bound of T squared. So if I work this out, I've got 4 times by 3.142 squared times by the lower bound, which is 51.95, and then I divide by the upper bound squared, so that's 1.455 squared. So if I work out this, I've got here instead 51.95, and on the bottom I've got 1.455. So I end up with over here 969.0181643. So this is what the lower bound of G is. I've got the upper bound and the lower bound.